Good morning and good afternoon, depending on when you're watching this. This is our first lesson on slope and writing equations of lines. And I think both of these concepts are review from Algebra 1, but we're going to spend some time going over them and really shoring up your understanding of what slope is and what an equation of a line is and what it means to write the equation of a line. If you look at the question that I have here, sometimes I do this as a class discussion, but I'd like you to take a moment and think, what is a line? We would use this word all the time. There's a line down the middle of the road, don't cross the line, the 30-yard line in a football game. So we have this idea of what a line is, but exactly how would we define line? In geometry, you went through a definition of a line, but I want to discuss some common misconceptions about lines. So I think pretty much everybody in here would agree that that purple mark there is a line. Now, where we might disagree is this a line? Some people would say yes, ignore like the, oh, there we go. Would say, well, sure it is. This is a wavy line. In math, there's no such thing as a wavy line. So in math, if you are going to use the word line, what you mean by that is what we would call a straight line. Now, a straight line, there's a misconception here. Students will often look at these lines and call them straight lines. That's not the best word. The word that you want to describe this is a horizontal line. And this one over here, the best word is a vertical line. We don't want to say a straight line because in math, all lines are straight. That I just drew is a straight line. It's not bending or curving in any way. So let's go to this key idea. How could we express this using good math language? Key idea is that lines have constant slope. So let's break this down. Constant means not changing. If the temperature is constant, it means it's not changing from moment to moment. The next thing we want to discuss is slope. So we have a slope that is not changing. Let's take a look at a picture on the coordinate plane. Remember, this isn't called a graph. This is called a coordinate plane. I'm going to put my line on it. If I were to measure the slope here, it would have to be the same as if I measured the slope down here. So the slope of that line doesn't change. So I have in the notes, if you're looking at the notes, 4 different ways that we describe slope. Let's go through the 4 ways to describe slope. And what I'll often do in a live lesson or a face-to-face lesson is I would ask students to generate everything that they can think of about what slope is, what they remember from Algebra 1. Let's go through this. One of the ways that students will often think of slope is rise over run. Rise, it means the vertical change, so think of rising up. If the sun rises, it's moving up higher in the sky. Run is the horizontal change, so if you were to run a race, you would run along the ground, you would move horizontally. And it's kind of nice that it's alliterative with rise and run. They both start with R. It's got this kind of rhyme to it, so slope is rise over run. Another common way students think of slope is they think of the letter M, and then they think of this formula from Algebra 1. And I'm going to make sure I say this out loud. These little numbers here are called subscripts. Sub meaning under, like a submarine goes under the water. It's a subscript meaning it is written just below or under the level of the x. And what they are intended to do is they are intended to make the x's and the y's look different. We wouldn't want to write y minus y, because y minus y would be 0. These are actually 2 different numbers, and the way that we make the variables look different is we put these subscripts. When I took Algebra 1, the gentleman that was my teacher, the way he said this, he would go y sub 2 minus y sub 1, and I couldn't understand what he was saying. So what he was saying was y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that's how you would say that. Now, the y-axis, we go back to our xy plane. This is our y-axis, is the vertical axis. That's your up and down, so that's your rise. And the x-axis is your back and forth, your horizontal, and that's your run. So I want to make sure I'm connecting these ideas for you. Another way that you might see it, I don't think this way is quite as common anymore, but you might see what's called delta y over delta x. That triangle there is not actually a triangle. It is the Greek letter delta, and I'll put that here. This is the Greek letter delta, and it is mathematical shorthand for the words change in. So it is the change in the y over the change in the x. How do you find change? You subtract. Okay, if I want to know the difference or change in my bank account from yesterday to today, I would subtract the two numbers. So, and you might be familiar with this, like maybe from sororities or fraternities or something. They use the Greek letters there. Last way that we might think of slope is rate of change. And this is most commonly used in word problems. So if you're asked to do a word problem, and depending on what you're asked for, you might be being asked for the slope. So I have an example, I have actually a couple of examples in the notes. It could be something like cost per minute, or something maybe like miles per gallon of gasoline. So if you were to graph or write equations for these relationships and you were asked, well, what is the miles per gallon? You would be asked for the rate of change or the slope. So let's just take this back to our picture over here. When we say that lines have constant slope, what we mean is the steepness of the line is the same everywhere. It never changes. So if you were skiing down this line, okay, if this were the slope and you were skiing down it, the steepness of the slope would be exactly the same all the way. If you were skiing down this slope, okay, the steepness is not the same. The steepness is changing, like it's horizontal and now it's getting steeper and now it's like the death plummet, and then it would level out. A line, mathematically, is a line that has that same, it's a figure graph that has that same steepness all the way across. Now, to calculate the slope, we need 2 points. If you are going to measure slope, if we're going to assign a number to it, what we need to have is 2 points. So I have 3 examples to illustrate calculating slope. The first one, we're going to have the point -3, 7 and the point -2, 4. If you were asked to find the slope, you would use this formula right here, y2 minus y1 over x2 minus x1. And when you go to plug it in, the 1 and the 2 are arbitrary. It's just for like 0.1 and 0.2. And it does not matter which point is 0.1 and which point is 0.2. If a teacher has ever told you that it mattered, it doesn't. But once you decide this is 0.1, this is 0.2, you can't change your mind halfway through the problem and decide you want to flip them. So you can make this 0.1 and this 0.2 or the other way around. Just once you decide, you have to stay with it. If you struggle with that, what I strongly recommend is that you actually write above the coordinates, like you have your x and your y, x1, y1, x2, y2. So for the sake of argument, I'm going to make this 0.1 and this 0.2. But again, remember, it doesn't matter. So this means that we have an x and a y for both, but we don't want to confuse them. So we have 0.1 and 0.2. That's where those subscripts come from. So we have x1, y1, and x2, y2. And now we can just do a straight substitution into our formula and then evaluate it. So if that sounds familiar from Unit 1, it's because it is. That's substituting and evaluating. So I've got m, and now I'm going to take y2, and if you write it above the points, it's just a straight plug-in, so y2 is 4. Now be careful here. There is a minus sign in the formula. So I'm going to bring down the minus sign from the formula. And then there is, oh, I guess we're okay on this one. Y1 is 7. Oop, I wanted to keep my colors constant there. There we go, 7. X2 is negative 2. And then here's where it's going to get messy. We have a minus in the formula, so I want to make sure I write it down. But then there is another minus coming with the 3. So you actually have 2 of them. You've got the one that's in the formula. You want to make sure you grab that one. And then you're going to grab another one from the X1. Sometimes people will put parentheses around that to make that look a little bit cleaner, so they'll do something like that. That is fine as well. You don't have to put the parentheses, just make sure that it's obvious that you have 2 negatives there. All right, and now we'll evaluate. So 4 minus 7 is negative 3, and then be careful. If you think back to one of our earlier lessons, there's no such thing as subtraction. There is just addition of the opposite. I'm going to do a little bit of scratch work over here. The opposite of negative 3 is positive 3, and negative 2 plus 3 is 1. So this is a 1. And then negative 3 divided by 1 is just negative 3. So the slope there is negative 3. If you are watching this video on your own, feel free to pause it and go back and work through that calculation again. Okay, let's look at another example. For this one, we're going to do the point 3, 1 and the point negative 4, 1. And our formula is y2 minus y1 over x2 minus x1. I don't require my Algebra 2 students to write the formula every single time, but I do encourage it. So on your homework, you want to be writing the formula. It helps you memorize it. The more you write it, the less likely you are to forget it, or the less likely you are to write it wrong when you go to take a test. Now, last time I did the point on the left was point 1 and the point on the right was point 2. So I'm going to illustrate that it doesn't matter. I'm going to make this point 1. So we'll have x1, y1, and we'll make the other one x2, y2. Just what you can't do is switch it up halfway through the problem and label your x's one way and your y's the other way. Okay, they do have to match. Just plugging in. y2 is 1 minus y1 is 1. x2 is 3 minus... So we have the minus in the formula. X1, and then we want to be careful with this again. We have the minus in the formula, and then we also have a minus coming in with the negative 4. 1 minus 1 is 0, and then 3 minus negative 4, just remember that to subtract a negative is the same as adding. And then please don't freak out with this. This is 0 divided by 7. So... if I have $0 and I divide them among everyone in this class, you're all going to get $0. If you don't believe me, if you are skeptical, in your calculator, go ahead and do 0 divided by 7. Your calculator won't steer you wrong. 0 divided by 7 is 0. And what that means is that you have a horizontal line. Okay, I'll try to do each of these out in a graph when I'm done. So we have a horizontal. Don't say it's a straight line. All lines in math are straight. Okay, all lines are straight. That was horizontal. All right, last example is we'll use the points 7, negative 3, and 7, 1. And again, you can pick whichever point you want to be point 1 and point 2. Sometimes there's clearly a better way to pick it. A lot of times it isn't, and it shouldn't matter. I'm going to make this point 2 and this point 1. Here's my formula. y2 minus y1 over x2 minus x1. Y2 is negative 3 minus y1, which is 1, over x2, which is 7, minus x1, which is 7. And I actually did pick that so I could avoid subtracting a negative. -3 minus 1 is -4, and 7 minus 7 is 0, and this is the problem, okay? 0 in the numerator, not a problem. 0 in the denominator, a problem. If I have $5 and I divide it among 0 people, okay, and I ask you the question, how many does each person get? The whole question doesn't make any sense. How can I ask you how many each person got? I already told you there were 0 people. So that's an issue. So this we call undefined. Okay, that's the vocab you want there. That's called undefined slope. And what it means is that you have a vertical line. Again, don't say straight line. Okay, it's a vertical line. Okay, a couple of words of caution. When you have this case, okay, or this case, all right, don't say this. The line has no slope. Okay, and the reason I don't want you to say that is because it's vague. When you say the line has no slope, do you mean it's flat, like horizontal? Like I'm going skiing today, but the trail has no slope, meaning like you're going to be flat all day? Or do you mean it has no slope as in slope is undefined? So when you are talking about one of these situations, I want you to either say the slope is 0 or you would say the slope is undefined. Please use the correct words there. Next slide, I'm going to take you through just what these look like, these 3 examples again. So we're going to look at the yellow example, the purple example, and the red example so that we can see what they look like. That first example, the red example, the 2 points were 3, 7 and -2, 4, and the slope was -3. If I look at my coordinate plane and I go to plot these, I would go right 3 and up 7. So right 3, up 7 puts me right about here. And then for this one, I would go left 2 and up 4. So left 2, up 4. And those are the 2 points. What I want you to notice about those 2 points is that the line it's not horizontal and it's not, something is not right there. What is not right? Okay, I found what was wrong and I'm 18 minutes into this video, so I don't want to like re-record the whole thing. Here's the mistake. I wrote 3, 7 and it should be -3, 7. So I am going to fix my graph with all of my apologies. Okay, trying it again. And just to turn everything into a teaching opportunity, copying stuff wrong, everybody does it, including your teacher. So don't get too frustrated when it happens. If it happens to you, you do what I just did. You realize something is wrong, and then you just go back and fix your mistake and move forward. It doesn't have to be a big deal. So with with the -3, 7, I will go left 3 and up 7, which will put me about up there. And then here I'll go left 2 and up 4 and connect them. And what I wanted to point out to you, which is how I caught that there was something wrong, which is exactly what I want you to do on your test. I want you to catch if there's something wrong. The slope for this is -3, and I know from Algebra 1 that a line with negative slope should be tilting downward from left to right. So as I move from left to right across the graph here, like this, it should be going down. My line was going up, which is how I realized that I had done something wrong and needed to go back and check my numbers. The next example was 3, 1 and -4, 1. And that one, the slope was 0, and I had written in the notes that that was a horizontal line. So if I graph 3, 1, I would go right 3 and up 1. And then -4, 1, I'd go left 4 and up 1. I hope I said all that correctly. And then when you draw the line, you should notice that it is indeed horizontal. So that's what your slope of 0 looks like. And the last example that we had was the 7, -3, and the 7, 1. So to graph this, I would go right 7 and down 3, which is, where is that? 1, 2, 3, 4, 5, 6, 7 is right about there. And then down 3. And then I would go right 7 and up 1. And there's your undefined slope. There's your vertical line, which is what I had said earlier. It was going to be a vertical line. Now, one of the things we're going to get into graphing lines using slope-intercept form. That's a couple lessons away. There are such things as vertical lines. But if every line that you're graphing is vertical, you have done something wrong. So they do come up, but just like when you're solving an equation and you get something like 5 = 4, it does happen, but it should not be happening all the time. So I actually alluded to this a few minutes ago when I caught that mistake in my work. But this is an important fact that is very useful. If you have a line with positive slope, it should tilt upward from left to right. If you have a line with negative slope, it should tilt down. And again, what happened in the other problem was I know this fact, and when I realized that my graph didn't match what I knew my slope to be, I knew something was wrong. Either my graph was wrong or my calculation was wrong, and I had to go back and find it out. So we are going to do how far do I want to go with this? We're going to do a practice problem. I'm going to put a practice problem up, and then we will go over it together. So I would like you to do the following. I would like you to plot the points 5, 4, and 8, 1. And then I would like you to answer this. What kind of slope is this? And by that, what I mean is I want you to tell me, is it positive slope or negative slope? And then I want you to actually calculate the slope. And I want you to confirm what you know about the slope with your calculation. Again, almost the same thing as what I did. I did the calculation first, and then I plotted the points, and I realized they didn't match. So you're going to do it the other direction. You're going to plot the points first, tell me what kind of slope it is, and then confirm by calculating it. And we will go over that in class together. All right, for those of you that are watching the video on your own, or you're watching it to make up from missing a class or just as extra review, I am going to go through this. So if you were to graph the point 5, 4, okay, I would go right 5 and up 4. And then the other one was 8, 1. So 1, 2, 3, 4, 5, 6, 7, 8. And I go right 8 and up 1. Now, the line, I can do better. Okay. So my answer to the first question, I know that because of the direction this line tilts, that this line has negative slope. So when I do the calculation out, I should be getting some kind of negative number. Here's my formula. I'm going to keep writing it down because I want to have the formula memorized. And we can pick the points in any order. I had the point 5, 4 and the point 8, 1. Now I'm going to choose to subtract these in a way that's going to avoid negative numbers. So I said it doesn't really matter which one you pick as point 1 and point 2, but sometimes there's a better way. I'm going to try to keep this positive. So I'm going to pick this as x2, y2. Actually, I guess I'm going to end up with a negative somewhere. And this is x1, y1. So here goes nothing. Y2 is 1 minus, sorry, my handwriting got really sloppy there. That is a y, and I just did it really sloppy. There we go. All right. And then this is just not my night for recording. This will show me to record these after I've been working all day. Okay, so 1 minus 4 over 8 minus 5. 1 minus 4 is negative 3. 8 minus 5 is positive 3. Negative 3 divided by positive 3 is negative 1. And we confirm what we answered above. And that is a very valuable check. And if you're not convinced it's valuable, you watched that check help your teacher find a mistake in this video, and now it's recorded for all posterity, your teacher making a mistake in a video and then fixing it. So there you go. All right, so that concludes the first lesson on slope and writing equation of lines. We basically spent the whole lesson on slope, and the next one will be writing equations of lines.